Okay, now let's have a look at how to solve a problem that asks for the molecular formula of a compound. So the process is almost exactly the same as finding the empirical formula. It merely has one extra step at the end. So let's start with the familiar steps so far. I suppose before that overview, in order to do this, you will first find the empirical formula, and then by comparing the molar mass of the empirical formula to the molar mass given here for the molecular formula, you'll find out whether or not they're the same, and if they're not the same, you'll find out how to get from the empirical formula to the molecular formula. But yes, we start by finding the empirical formula. So here we go. We take, just as before for empirical formula, we take this information and figure out the ratio of the moles. So convert these to moles, find the ratio of moles, and that'll give you the empirical formula. That's the beginning of this. And as we discussed before, anytime it gives you percent composition, just assume it's a 100-gram sample, which means you can replace this percent sign with a gram sign. So out of a 100-gram sample, you'd have this many grams of carbon, this many of hydrogen, and you go from there. So we begin with that. 92.25 grams of carbon, and we'll convert that to moles using the molar mass and labeling the elements as we go through. And before doing that on the calculator, let's do the other element as well, the 7.75 grams of hydrogen, also converted to moles. Let's see, we'll put use grams per mole. So 1 mole is 1.008 grams. And now we can do the conversion. So let's see, is that in view? Yes, it is. Okay. 92.25 and that's 12.01 is 7.681 grams, or whoops, sorry, moles of carbon. And let's do the same for hydrogen. 7.688 moles of hydrogen. Looking at this right now, these are basically the same number, and to reinforce that, let's divide both by the smallest one. Okay, this one's slightly smaller of the two, so divided by 7.681, 1 mole of carbon. There we go, 7.681. These are basically the same in here. Let's see that on the calculator. Look at how close that is to 1. We can call that 1. So basically these exist in a 1-to-1 ratio, which means the empirical formula is simply a 1-to-1. Which means the empirical formula is 1 carbon and 1 hydrogen, CH. That's it. That's the empirical formula. But of course, we're not looking for the empirical formula. We're trying to find the molecular formula. So here's the plan. We need to see how the molar mass of this compares to the molar mass of the molecular formula. If the molar mass of this is half of what it should be, as in like if this turns out to be half of this, we times the formula by 2. If it turns out that it's only a third of this, we times it by 3. If it turns out it's a fourth of this, we'll times it by 4, etc. Okay, so let's see. What is the molar mass of this formula? So molar mass equals 12.01 grams per mole. That's carbon. Oops. Plus 1.008 grams per mole. That's the hydrogen. Which, okay, that's the molar mass right there. 13.02 grams per mole. Remember, we always round molar masses to 100th place. Okay, so the molar mass of the empirical formula is 13.02. The molar mass of the actual thing, the molar mass of the molecular formula is this. So however much bigger this is compared to this, we need to multiply the entire formula by that much. Let's see. We need to find ratio of molecular formula mass to empirical formula mass. Okay, so molecular formula mass 78.11. Empirical is a 13.02. Well, let's make that into a division problem. How much bigger is the molecular compared to the empirical formulas? Well, 78.11 divided by 13.02. We're going to call that 6. So molecular formula 6 times larger. Okay, so what that means is the molecular formula is 6 times this. Well, if I multiply this by 6, isn't that C6H6? So 6 times empirical formula. Is that in view? Ah, there we go. Now you can see it. Okay. So 6 times empirical formula equals molecular formula. Okay, so that's 6 times the empirical formula equals the molecular formula. That would be C6H6 as the molecular formula. Just like in any math class you've ever taken. If you multiply something, we'll put the formula in parentheses. If you times something in parentheses by a number, the number has to be distributed. So 6 times carbon and 6 times hydrogen. That's where that came from, and that's why this is our final answer. Okay, well, how about a little practice? Okay, here's some practice problems where you can see questions similar to what was just solved. If you want to give these a try, pause now. I'll put the answers up shortly. And here they are. Here's the first one. Trying to get them all in view for you. And here is the second one. Okay, that's it.